We are looking at the key for the mole ratio lab. So in this lab, we took iron and we combined it with copper chloride to form copper and iron chloride. You didn't need to put subscripts down here, but I did. We took iron nails, which was a solid, and we put it in copper chloride, which was an aqueous solution, which means that it was a powder dissolved in liquid. The copper chloride turned into a solution. Then we formed solid copper, and then this was a solution of iron chloride. So what happened is everything is balanced here. Copper is +2, iron's +2, Cl's -1. So everything combined in a 1 to 1 to 1 to 1 ratio. We kept track of the iron and the copper in this lab. For every atom of iron we should have used, we should have produced 1 atom of copper. Or for every mole of iron atoms, we should have produced 1 mole of copper atoms. But we're not comparing gram to gram. We're comparing mole per mole or atom per atom. This question here, observations, this is really any irrelevant observations from the end of day 1 or beginning of day 2. Let's look at our data and just make sure we understand how we got that. So we're asked to work with iron nails, okay, and they weigh 10.32 grams, have some here. I put it in this solution, it ate away at the nails, so they weighed less, and how much iron was consumed, it would be the difference in the nails. So I subtract that, I get 1.44. I divide that by the molar mass of iron. So the 1.44 divided by that, I get this number. And I do want to report that with 3 significant figures because I have 3 figures right here. So the 0 is important as a placeholder, but not a sig fig. So it ends up being 0.0258 moles of copper of iron that was consumed. I'm going to do the same type of reasoning for figuring out how much copper was produced. I have a beaker, I weighed it empty, and I weigh it with the copper in it. It has the copper in right now. And the difference, when I subtract that out, is 1.59 grams. I divide that not by 55.8 up here, I divide it by the molar mass of copper, which is 63.5. I get 0.0250 moles. Okay, so these two are really close, but it looks like the moles of iron is just a little bit bigger when you look at that third significant figure. Okay, so it says to take the ratio of this. So you take your answer for moles of iron divided by your answer by moles of copper. I get just over 1.0 as my ratio. Ideally, that should be a 1-to-1 or 1.00 ratio, meaning for every mole of iron atoms, I should have 1 mole of copper atoms. So we don't have much error because we're at 1.03 instead of 1. How do we figure out percent error? You take the accepted value, which is 1.00, minus the experimental value, which is 1.03, divide by the accepted value of 1, times it by 100. Technically, I get -3%. Sometimes we'll just ignore that negative sign, meaning the experimental value is higher than the accepted value. If you keep the negative sign in, that's fine. These 3 and 4 interesting questions. There's 2 big errors that can probably occur in this lab, and they don't really involve the iron. I mean, you're putting these nails in, you're weighing them before and after. So unless you make a mistake on the scale, that should be pretty accurate. But getting the iron, it's all dirty, okay? It's got, if you look back at your equation, this iron might be coated with some of the, this copper that you get at the end might be coated with some of this reactant that wasn't used up or some of this product right here. So you got to wash it so it's just copper and not leftover this or not this other product right here. So we had to do a sequence of 3 washes, or actually 4 washes with this substance here. So then we talk about some possible errors. What if I maybe washed it too many times? Every time you wash it, you're pouring it down the sink, you might lose a little bit of copper that shouldn't be gone. So you keep washing, you keep washing, you keep washing, you lose a little bit of copper. So your denominator decreases as you lose copper, which makes what? If the denominator decreases, the numerator stays the same, it makes your mole ratio actually appear to be bigger as the moles of copper decreases and iron stays constant. Okay, you see the opposite effect with the other possible mistake is not washing it enough. So if you don't wash enough, you probably got some impurities on there, okay? Some iron chloride or whatever, iron chloride or copper chloride or whatever. So you get the opposite effect. Your moles of copper is too big because you have other stuff with it. You're overestimating it, which makes your ratio, the denominator too big. It makes your mole ratio too small. And then the last answer here are some ideas, but again, any relevant description is going to be okay. What happens at the molecular level. Hope that helps. Thanks for watching.